Continuing 13.2, Wildfire as a Process. We just discussed the first two phases of a wildfire, pre-ignition and combustion. The third wildfire process is extinction. This is the point at which combustion ceases because there is no longer enough oxygen, heat, and/or fuel to sustain fire. The image is of an extinct wildfire. The fire needs to be totally out, and as you probably know, a fire can look like it is out, but be hot enough to start up again with a bit of encouragement, such as wind. So sometimes, for a wildfire to be officially declared to be over, the area needs to be totally drenched with a rainstorm, or poor wildfire fighters go through the forest on their hands and knees doing hot hands, basically feeling the ground with their hands, and if they get burnt, then the fire needs a little more putting out. Yep, I'm not a wildfire fighter, but some people love it. So here's a bit of a self-quiz. Can you identify the phases of a wildfire on the image below? Here are the different phases. Pre-ignition with the subphases of preheating and pyrolysis. Combustion with the two types, flaming and glowering or smoldering. And extinction. Take a moment and place each phase and subphase and type. Okay, see if you were right. I would place pre-ignition here, with preheating here, and pyrolysis here, about. I'm kind of imagining the trees would be looking a bit like burnt toast here. Here. Even though they are colored a healthy green. I would place combustion here, with flaming here, obviously, and smoldering or glowering here. And extinction I would place here and further to the left of the image. Okay, now try the self-quiz again without me giving you the words. Can you do it? Okay, here's the answer again. I would place pre-ignition here, with preheating here-ish, and pyrolysis here. I'm kind of imagining the trees would be looking a bit like burnt toast here, even though they're colored a healthy green, right? I would place combustion here, with flaming here and smoldering or glowering here. And extinction I would place here and further to the left of the image. I've gone over this twice. Do you think you might see it again? Hint, hint. Now we're moving on to fire environment, which is how fuel, topography, and weather affect the wildfire. Take a moment of pause to consider how these factors affect the wildfire hazard. Well, we've kind of already talked about topography, and we've mentioned weather a bit, and even briefly mentioned fuel type. Let's go on to discuss each factor affecting the fire environment a bit more. Fuel. Fuel size affects ignition and movement. Just compare how easy it is to light little pieces of grass versus a whole log. Also consider live fuel versus dead fuel. wet fuel versus dry fuel, oily fuel versus less oily fuel. Yes, some wood has more oils in it and so burn easier, as in eucalyptus trees. Fuels are often produced as a previous natural hazard, damaged trees, and clumped together combustible debris. These hazards could have been a landslide, hurricane, tornado, or something else. After about 15 to 30 years, the downed trees are dry enough to be great wildfire fuel. This type of clumped up dead tree pile is depicted in the image on the left. Organic rich material that has been dried out is another great wildfire fuel source. Things like a dried out swamp or peat often lead to ground fires that can last for months. These fires are hard to locate and even harder to put out. This type of peat ground fire is depicted in the image on the right. This ground fire occurred in Spain in 2009 when the weather was very dry and water content was very low, less than 20%. Only weak plumes of smoke could be seen in holes distributed over a surface area of about 110 acres. The real magnitude of the fire lies below the surface and no one knows the size of it. The type of fire, the speed of the fire, the extent of the fire are all affected by the fuel. Topography also affects a wildfire in a couple ways. We've already mentioned that a slope helps in heat transfer and can speed up the progress of a wildfire. In addition, we've already mentioned a bit about slopes and wind, but here's a bit more info. Mountainous areas circulate winds up canyons during the daytime and often down canyons in the nighttime due to the temperature gradient of the air with elevation. Topography can cause wind, and winds definitely help the spread of a wildfire, especially if the wind is blowing upslope. That's basically the worst, if you don't want the fire to spread. So these are things we've kind of already discussed. But did you know that fuel moisture content is affected by location on a slope? Drier fuels are found on south-facing slopes in the northern hemisphere and on slopes exposed to prevailing winds. This is nicely depicted in the picture, with the north-facing slope covered in relatively lush, woody, harder to burn, shrubby trees, and the south-facing slope is covered in dry grasses, which are very easy to burn. And even nicer, at the top of the canyon, the slope is covered by both types of vegetation. Weather also affects the fire environment. Fires are common following droughts, especially when a dry thunderstorm occurs with no precipitation but lots of lightning. Often what little rain occurs in these systems evaporates before it hits the ground, called virga, which is useless for controlling wildfires. The image shows virga, the dark gray streaks, with lightning that reached the ground. Maybe a fire resulted. Who knows? Fires burn more when humidity is lowest and when windy, as wind direction and strength help preheat unburned materials. And winds carry embers to ignite spot fires ahead of the main wildfire front. Very annoying and dangerous. These spot fires can start miles ahead of the wildfire front. Okay, on to types of wildfires. There are ground fires, surface fires, and crown fires. Ground fires are mostly underground, smoldering, but you can sometimes see flames at the surface. Surface fires are the brush and undergrowth and sometimes the lower parts of trees that burn. And crown fires are the crowns or tops of the trees burning. These are the most dangerous for wildfire fighters to fight on the ground. Fighting ground fires often has a lot of air support, like helicopters dumping buckets of water or fire suppressant. Okay, can you match the type of fire with the pictures on the right? I bet you got it right. Top image is of a ground fire. Middle image is of a surface fire. And the bottom image is of a ground fire. The most exciting ground fire image I could find. I tell you, ground fires do not look impressive, but they are in terms of how long they can burn. Months and months and months. Again, ground fires creep along mostly under the ground surface. There is a little flaming, more smoldering. The fuel type that they burn are generally duff, as in decaying organic matter in the soil, drained or temporarily dry swamps and marshes, and thicker peat deposits below the soil. Image is another very exciting ground fire image. Most ground fires mostly just look like normal, nothing happening forest picture. So yeah, this is an exciting ground fire picture. Surface fires move along surface and vary in intensity. A low-intensity surface fire burns slowly with smoldering, limited flaming. A high-intensity surface fire burns quickly, very hot. Fuel type is generally grass, shrubs, dead and downed limbs, leaf litter, and other debris. So is the image a high-intensity or low-intensity wildfire? Right, high intensity. Ground fires is flaming, is combustion carried via tree canopies. It may have started as a surface fire but climbed or jumped up to the treetops. Ground fires are often driven by strong winds and occur in areas with steep slopes, which aid in the pre-ignition phase of neighboring treetops. Ground fires are very hard to stop, very dangerous. Image is obviously a picture of a ground fire. 13.3 Geographic regions at risk from wildfires. The map shows wildfires greater than 250 acres from 1980 to 2003, indicated in a red dot. What do you notice about the pattern of wildfires in the United States? Well, one thing I see is that Idaho is a pretty red state. Seriously. Much of the West seems to have a much higher incidence of wildfires than the Plains states, the Midwest, and the East. Alaska also seems to have a high incidence of wildfires in the interior away from the north and south coasts. Anything surprising about this map data? I am surprised by the Everglades burning so often at the tip of Florida. I've been to the area and it is wet and swampy and mosquito-y and alligator-y and crocodile-y. Not a place I would picture being able to burn. Ever. But when the water table is low, there is plenty of organic material that can burn once it dries out. And we already know there are plenty of severe storms to produce lightning to set off the fires in the first place. So in general, areas that are near grasslands, woodlands, shrublands, or tundra are at risk of wildfires during drought. Even deserts, rainforests, marsh, and swamplands can experience wildfires. Large wildfires are most common in Alaska and the western contiguous states in the United States and in the Canadian Rockies, possibly because there is more open space with forests and grasslands to burn in the first place. It's hard to get a wildfire in a city. Fires, sure, but not wildfires. Interestingly, there is a belt that extends from the Yukon Territory southeast to Lake Superior, then east to Labrador, where there is relative high incidence of wildfires. The wildfire risk area tends to shift from year to year as the fire environment changes. Due to